Okay, so this lab is entitled Acids, Bases, pH, and Buffers. And today we're going to examine the pH of a number of commonly encountered household items, and we're going to test the pH two ways. The first is with a readily available indicator solution called Universal Red Cabbage Indicator, and the other way is with an electronic pH meter. And part A of the procedure tells you how to prepare the red cabbage indicator and to standardize it. However, we will be skipping that part because we have a useful universal indicator color guide, which will be included as a freestanding photograph along with this lab video for you to consult when making predictions about the pH of your solutions. So what we're going to do first is prepare each of our 10 household liquid solutions, and then we are going to add the cabbage indicator to each test tube and then mix them up and record the color. And there should be an obvious color difference for many of these, and hopefully it's visible on the video. The second thing we're going to do is prepare another 10 solutions in small beakers of the same household items and record the pH with a digital pH meter, and then you will compare the two measurements in your lab report. So we begin by putting 2 milliliters of each solution into their respective test tubes, starting with shampoo. This is a 10% shampoo solution. So there's 2 milliliters there. Next one is mouthwash. And then we have antacid. And then we have Tide, which is 5%. Next is lemon juice. And then vinegar, 10% vinegar. Then aspirin. And baking soda. This is a 5% baking soda solution. Then ammonia. And finally, seawater. And then we finish out by adding 2 milliliters of each of the indicator solution to each of the, or a small amount of the indicator solution to each test tube. So take our dropper, put that there. Notice it's a light pink color coming out of the jar. And notice that several of these have different colors already. So now we can see that a number of different colors have begun to make themselves known. We'll swirl these around a little bit to make sure they're fully stirred. And you should note the color of each of these to compare to the handy chart that we have in this index card. Alright, and that's the indicator portion of this pH test. Now we're going to take the same solutions and measure them again without the presence of an indicator. And so we'll just line these up, fill them with the same solutions in order, and measure them with a pH meter. Okay, so we're going to take a close-up of each of these. The first one is the shampoo. You can determine for yourself what color that is closest to. Next one is mouthwash. Third one is antacid. Fourth is Tide. Fifth is lemon juice. Next one is vinegar. Next is aspirin. After that's baking soda. Ammonia. And seawater. So you can make your own conclusions based on that. Okay, so for the next part of part B, we're going to measure the pH of the same solutions using a pH meter. And so we're going to use a small beaker for each one of them, and we're going to place a small amount of this liquid into the beaker, starting with shampoo. We put in just enough to immerse our electrode, and then the important step before every pH measurement, It's right now in water, and it's reading a 6.68 pH, which is roughly as expected. We always rinse our electrode with distilled water before we take a measurement. And then we place our pH meter into our water, into our solution, and mix it around. We measure. And the pH continues to drop. We may not have put enough shampoo into this beaker to get a good reading, so I'm going to add just a little bit more. Now the electrode is fully immersed. And just to make sure that we have a good reading, I'm going to hit measure again. And it looks as though the pH is fairly steady at 5.65. So the pH of shampoo is we'll say 5.6, or if it continues to go down, then all right, we'll call it 5.55. It's going to keep changing a little bit, but it's generally 5.55. Now we rinse our electrode off after that run. Place it back in the water that it was in. And then we dump our waste. Move on to our next solution, which is mouthwash. So now we measure this again in water, and we see the pH has gone back up. And the pH is roughly at the place where it started. So now we take our electrode again, rinse it with distilled water, and we place it into the mouthwash solution. Now you'll see the pH has increased. That's interesting. Increased and then decreased. So now we have a pH reading of about 6.18. So that's also lower than before. So we'll take our electrode and we'll rinse it again. We'll place it back in our test tube to rest while we dispose of our waste. And we wait for our pH to re-stabilize. And now it's gone back to the value that it was at when we started. So we now add antacid solution to another beaker. And we take our electrode, shake the water out of it, pour the distilled water, and we put it into our solution, stir it around a little bit to make sure that we have good mixing. And as expected, our antacid has a higher pH than 7. This one is reading about 8.41. So that's an antacid solution. We rinse our electrode off again after that experiment. Shake the water out of it, place it back in our holding solution, and dump our waste. And then we move on to Tide. Of course, we measure so we get back to where we were. And we're back, of course, to 6.8, which is roughly where we started. And now we have our Tide solution. Now the Tide, measure, rinse off between each run. Place it in the Tide, stir it around, measure. And we see again, we have a higher pH. This one is reading 8.4. So, slightly alkaline. And we dump our waste and move on to our fifth solution, which is lemon juice. You can see every time we put our electrode back in the holding solution, it regains its pH of close to 7. Now we do lemon juice. Place this in the lemon juice. Hit the measure button. Now notice the lemon juice is very acidic. It has a pH down around 2.3. So now we rinse our electrode off and we place it back in its solution. And we pour out our waste. We move on to our next solution, which is vinegar. So now that we're reestablished pH 7, we can rinse this off again, and we can place it into our vinegar solution. Now the vinegar, believe it or not, has a higher pH than the lemon juice, and that pH is about 2.87. So now we do our rinse. And we dry this off. Stick it back in our holding solution, pour our waste. Now we move on to aspirin. Right, so now we rinse this off again. We place it into our antacid solution. Our aspirin solution. And we see the pH of aspirin is about 2.57. Which makes sense because another name for aspirin is salicylic acid. Place it back in our wash bottle. Pour our waste out. And move on to baking soda. Now, pH of our baking soda. It's measuring 8.35. Pour our waste, and then we do our ammonia solution. Right, now ammonia is very basic, has a pH around 10.85. And we pour our waste. That'll make a cool color. And the last one that we're going to do is seawater. So we take our pH meter, we rinse it out again one last time. Can wipe the outside. And we place it in our seawater sample. And we measure 6.88 pH for seawater. And we store our pH electrode as we found it in a sample of water. Dispose our waste into this jar. And since all of these are over-the-counter, commonly available substances that are considered to be reasonably environmentally friendly, we can take all of this and pour it into the drain. So that is part B of the acids, bases, pH, and buffers lab. Okay, so in part C of the acids, bases, pH, and buffers lab, we're going to be testing the effect of the addition of acid and base on the pH of a number of solutions. We have out here 2 copies each of water, sodium chloride, and a low and high pH buffer solution, to which we're going to add 2 milliliters of the cabbage indicator solution, like so, as we did in part 1, where we've established that this indicator does in fact work. Notice the low pH has the same pink color as the cabbage indicator would normally have, and the high pH has the blue color. So now we've established that our initial solutions, which should be first 2 neutral, low pH should be slightly acidic, and high pH should be basic, according to our card that we consulted at the beginning, in which we will include in the lab report. You can see the pH is roughly accurate. So to the first set of 4, we're going to add 5 drops of 0.1 molar hydrochloric acid solution. And we'll swirl them around. Now you can see that there hasn't been much of a color change in either the pH 4 or the pH 10 buffer. The water and sodium chloride solutions got slightly redder when we added the hydrochloric acid. So now we are instructed to add 5 more drops to each vial. You can see that the first 2 solutions have darkened in color, while the pH 4 buffer has held its solution at a lighter pink, and the pH 10 has lightened slightly, but has not lightened very much. Now we're going to test the addition of sodium hydroxide on the same solutions, but without the hydrochloric acid added. So the first one, we'll add 5 drops of sodium hydroxide. So you can see the first one has changed almost immediately to a greenish blue. Similarly for sodium chloride solution, once we mix it up, it pretty rapidly settles on a greenish blue. The pH 4 buffer, however, has stayed pink, and the pH 10 buffer has stayed blue. So now we're going to add more sodium hydroxide. And if you'll notice, the first two solutions have basically landed hard on the greenish blue. pH 4 solution is still at pink, and the pH 10 solution is still at bluish green. Now if we were to measure the various pHs of these, we can do that. As expected, the H2O solution with hydrochloric acid added to it has gone down to a pH of 2.5. And the sodium chloride solution has also gone down to a pH of about 2.4. The pH 4 buffer is sitting right around 3.55, so it has resisted the acidification. And the pH 10 buffer comes in at a solid 9 point. Oh, it's actually right at 10. So it stayed rock solid at about 10 pH. Now we can test the same in the basic solutions. So the water with base added to it went to a pH of 11.6, which is quite high. The sodium chloride with sodium hydroxide added to it also went up to a high pH. This one is 11.6 as well. Now our pH 4 buffer has increased a little bit, but it's still around 4.6, which is pretty robust. And finally, our pH 10 buffer has also resisted increasing its pH and is hovering around 10.3. So that is buffers. You will be asked in your lab report to explain why this phenomenon occurs and to make observations based on these experiments.